All right. Good afternoon, guys. Gosh, it is like church. Good afternoon. First day of Pass. There we go. All right. Welcome, guys. You guys must be all East Coast timers like me right now, and a little tired. Welcome. My name is Brian Knight. I'm with Pragmatic Works. Today we'll be talking about how to make money on the internet. We'll go through some very easy steps on how to make money with lottery tickets on the internet. All right, well, I'm just kidding. Actually, this is an analysis session all about data mining. I do have a pretty dry sense of humor that nobody really gets. I think I was British in a past life. My Twitter handle is @BrianKnight. I'm a SQL Server MVP out of Jacksonville, Florida, where I've been all my life. That's why you heard Leonard Skinner beforehand. They're Jacksonville boys. Oh, no. And that's where you're not supposed to hear Leonard Skinner right now. That is a great new program that won't close. Wow. That will make the past outtakes. Okay. So, I'm the founder of Pragmatic Works, where we do a lot of BI solutions. We do training, we do software, and we also do consulting. And I've authored a number of SQL Server books, 13 or so. Actually have one I'm going to be giving away today, and we'll be giving away 100 books at our booth after this. So if you come, we actually have all the authors of the books coming, but you have to be in line within the first 100 people. I also blog at a website called bidn.com. It's the BI Developer Network, and it's a free community website for BI developers like yourself. All right, so hopefully you guys how many of you guys, just about yourselves, how many are developers here? Wow, okay, and DBAs, and all the above. For those that are listening to this session, the recorded session, there were about 9,000 people that raised their hand. Okay, that'll be our little joke. Okay. All right, so, and how many have done data mining already with SQL Server? And that's the usual answer they get, about 3 or 4 hands that go up. Well, today we're going to do a session all about, it's an introduction to data mining. It's my favorite topic to cover. There's nothing that can transform a business faster than data mining. I mean, nothing. I'm an SSIS bigot, and I saw data mining, and I was won over. Hallelujah. It is a really, really neat technology, and it's something that when you see it, you're going to just go crazy. And your business sees it, they'll go crazy also. For example, we had one customer just recently, this is about a year ago, when the economy tanked, they decided to do some data mining project to reduce the amount of catalogs they were mailing out. And they wanted to reduce it by 60%. Well, they were able to reduce the catalogs they sent out by 60%, but get 80% of the results. And they were saving close to $80,000 a month from a 1-week data mining project. That's what it can mean for your business. Now, as far as what it can mean for you guys, if you think of a pyramid like this is not a pyramid scheme in any way. All right, let me turn it on, zoom it here. The tool I'm using today is Zoom It. I always get asked that question. It's a free tool from Microsoft, and it allows you to kind of do a little Madden stuff, bam, on your screen. But it's a really kind of neat tool. So when you think about a pyramid of BI, okay, something like that, and you're thinking about, let's kind of go up the pyramid of commodity skills to more really specialized skills. Kind of on where the most number of jobs are going to be your report writers, your SSRS developers, those kind of positions. So I'll kind of put those, not that there's anything wrong with that, great positions. That's kind of the get you in the market, right, kind of thing. Above that, you'll typically see like your SSIS developers. And this is also the salary pyramid also, probably. So you see the SSIS developers. And how many SSIS developers are here? How many have developed a cube in the past? Okay, wow, quite a few of you guys. So we have our SSIS developers up here. Hopefully you're seeing a higher salary from learning AS, because if you know MDX, then you are pretty cool. The last piece up top is what we're seeing now is people are developing that BI solution. And they've kind of been building it because the economy really stunk. And they went up that pyramid. They said, all right, I've got a data warehouse finally. Now what? I've got all this massive amounts of data, terabytes and terabytes of data. We have one company that has close to 300 terabytes of data they're looking at for transactional data. It's a big bank. And they wanted to figure out what next. Well, that's where the session that we're doing today is really, to me, is the top of the pyramid. And in my county, Jacksonville, Florida, it typically means about a 20% perk in your salary if you know data mining. So that's what's in it for you guys. The learning curve is not as high as things like MDX, but there's so few people that know it that it can really help your skill set and your salary long term. This is completely made up, by the way, but it's highly scientific based on, I don't have the facts to back this up, but you'll get a big raise. Okay. No, I mean, just from what we see in job postings, we do a lot of staffing and consulting, and we see a lot of, when they ask for data mining and they ask for MDX, that's going to be a big perk. So, what can data mining do for your company? Well, it's going to do a few things. It's going to let you explore the data you already have, let your business analysts find patterns in that data that they may not know you have. So who is a good customer and who is a bad customer historically? Let's find that. Let's kind of find that profile of customers to figure out who's going to buy our products in the future. Because our marketing budget just got shrunk. Who needs marketing? Lastly, it's also going to perform predictions to find out who is good and who is bad based on new data coming in. So you have all these trends and all this data in the past. Well, let's use those trends to find out what's going to be good in the future. Okay? So on this 150-slide journey through data mining, I'm just kidding, guys. I'm not going to do 150 slides. I have about 8 slides. All right, so let's go ahead and start with what can it do. So this is the last session. I got to figure out to wake you guys up somehow. The process is basically a very standardized process. And this slide deck's up on PASS website if you want to download it also. There's tons of notes in the slide deck. So if you can go ahead and steal all my notes, go for it. First of all, we have to, and people take this for granted, understand the question that you want to ask data mining. You just know I want to do some kind of cool skunkworks project, maybe, but you don't know what question you want to ask. If you raise your hand if you're a DBA, maybe the cool question that you can ask as a skunkworks project is, what is the performance of this server going to be in 2 weeks based on the trends I have? Oh, over the holiday, it's going to go to the roof. I better watch out. I better add more capacity, perhaps. That's a really cool skunkworks project you can do as a DBA today that won't really involve the business. You can just kind of try it out and see how it works. After you figure out what question you want to ask, the next thing is, where am I going to get the data to support that? So, for example, we had a financial company who was looking at ticker data, and they wanted to figure out what the price of the stock was going to be in 20 minutes. And they had loads of ticker data they were loading in every single second. And as they saw a trend, they were able to predict that price going forward about 3 units at that time. So knowing where to get the data is always the hardest part. This takes the longest, is preparing the data. This is usually an SSIS step. It could also be a T-SQL view also. So this is the hardest step. It's kind of merging the data, kind of flattening the data, however you want. But the cool thing is, how many have warehouses here? Data warehouse. So quite a few of you guys, most of you guys, about 7,000 hands went up that time. For the ones that did not raise your hand, you don't need a data warehouse to do data mining. You don't even need a cube to do data mining. You just need a table. Okay? So that's one of the misnomers we find with data mining is people think they had to have a cube and all this fancy stuff already done. I love cubes, but you don't have to have it. So preparing the data is the next most important step. And this is a standard kind of methodology, by the way. CRISP is a real standard organization. After we do that, now involves the modeling. So think about going back to high school science, and before you throw open your mouth a little bit, think of that, I have a hypothesis that I want to prove, right? And you had the hypothesis, and you had to do a whole bunch of things like create control groups, and you created groups over here, and you had to prove it right or wrong back in high school or college, or a lot of you guys probably didn't graduate from high school like myself. But anyways, and that modeling step, we're basically trying to prove that hypothesis right or wrong. And once we think we have a good hypothesis, a good theory, we evaluate it after that and actually prove it right or wrong. So the evaluation step is all built into analysis services. Once we do that, we deploy it, and we're all done. So it looks like this from a technology perspective. There we go. We have our data. We get some light data profiling with SSIS. We can prepare the data with a SQL Server view, or even just a cube by itself, or it could be a cube, it could be a data source view, it could be a SSIS, whatever you want. The goal in that data preparation state is to flatten the data. All right, after we do that, we're going to model the data next. This is not like a supermodel or anything. This is just taking our hypothesis, throwing the fields at it, throw all the evidence at it, and let's see what sifts out. And then we evaluate it after that. All that's done inside of analysis services, which takes care of all those steps for you. So, this is my biggest slide, one of my last slides. What are the algorithms that we can use in SQL Server data mining? So, in SQL Server data mining, the core two that you really care about, that you really need to master, are decision tree and clustering. So let's kind of dive a little deeper in those. And we'll do a long demo that shows most of these here in a second. So a decision tree is basically asking a whole bunch of what-if questions. So why in the world did my wife marry me? Well, don't answer that, please. You hurt my feelings. But maybe first of all, she actually put up with my bad jokes. Okay, go down that direction. I wasn't 90 years old. Okay, that was probably a good thing. And it's so on and so on and so on. So there's a whole bunch of branches in the tree that ultimately led to a decision. And that's the picture you're seeing in that top left, the decision tree. It's the most common algorithm for data mining out there, really. So it's good for doing classification projects, for finding out who is good and who is bad, or who is a female and who is a male, kind of classifying customers or ages or whatever. Who's going to buy a product from you? It's a decision tree. Clustering is really geared at fraud detection. Again, it's all the notes in my slide deck also, so if you download those, you'll have all those notes. So for fraud detection, picture a graph that looks something like this. All right. Oh. Okay, second whiteboard here. All right, there we go. Yep, and there we go. All right, so picture something that looks like this. We have a 2D graph in this case, but really it's probably more like a 3-dimensional graph. And as we go through this, we would have something like, how about we do occupations over here? And how about salaries? So when I was working for an insurance company, it was cheaper for us to automatically underwrite a policy for term insurance than it was to send it to an underwriter. Does anybody work in healthcare here? Or insurance? Sending it to an underwriter is quite expensive. So we wanted to find a way to automatically underwrite those kind of commodity term insurance and those kind of things. So what we did is we wrote hundreds of thousands of lines of code to figure out, well, are you good or bad, basically? Are you lying to me or not? But what we could have done, and what we wound up doing in the final stages, was we did something like this. We had, really, it's a 3-dimensional graph. I'm showing 2D. So imagine we have a farmer in Wisconsin right here. And he makes, $20,000. Pull a dot in the graph here. And then I've got another farmer somewhere in the Midwest. He makes, how about we give him $35,000. And we have some lawyers over here in New York that are living in La Vida Loca. All right, so over time, we start to get clusters of data, right? And we can kind of draw little circles around them somehow. Now, I say we can draw circles around them. Maybe I do need a mouse. All right, what's that? This is not the beta version. All right, so what we have here, we basically can say these are our Midwest farmers. Over time, we start to see a pattern in that data, right? And up here, maybe our New York lawyers, our Northeast lawyers. Okay, so I misspelled. Well, anyways, so let's imagine all of a sudden we get a Midwest farmer, some farmer from somewhere in Idaho, who comes in tomorrow and says, you know what? I actually make a lot more money than that. I make $200,000. And I'll put a point in the graph right there. So what clustering can do for you is measure the distance between him and his peers. And it will say, you know what? Looks like this is not a good record. It's 0.02% chance of actually being accurate. It'll measure that for you and give you the likeliness of that actually being a valid record. Okay? So it's great for fraud detection. It's great for if you have any kind of call center application. They can just, they're all typing in that data all day long. If they hit go and it actually messes up, you can flag it as an incorrect record or manager approval needed or whatever. So all those kind of things, ultimately what we did at this insurance company is it reduced the lines of code from over 100,000 lines of code. It was 120-some-odd thousand lines of C# code to see if it's a valid record or not, down to a few dozen lines of code. And it's kind of like Skynet. The more it learns, the more smart it becomes, and eventually takes over the world. But we won't talk about that now. Let's go with it. All right, so that's the clustering algorithm. Time series and algorithm is really for predicting a number. So let's imagine you want to predict your home value. Don't cry too much, but your home value 2 years from now. Time series is going to predict that number for you. Or a ticker price, a stock ticker price. So if you're looking for concrete numbers of how much something's going to be worth, time series is what's for you. So at most companies I've been at, when it comes to budgeting, how well is this sales guy going to do versus this sales guy? It's a number out of the air, And let's take last year's number and add 20% to it, right? Sounds good. Let's go with it. So what this can do for you guys immediately, every single person here has sales. You have inventory. You have things like that. Oh, no? You have no sales? We still have sales, otherwise you can't get paid, right? Okay, anyways, what kind of nonprofit are you? Credit count. So you have number of calls coming into your call center then, right? So you have some kind of number like that, and you can predict that number 2 days from now. Are you going to be properly staffed on a Saturday for that influx of calls coming in because you ran some kind of ad or whatever? So this time series analysis is all about predicting those numbers, those hard and fast numbers. So whether it be a budget, number of calls that are going to be received, number of sales from a sales guy, the amount of inventory, those are all things that can be answered with time series. What's amazing about this one from a project that we did recently, I keep on hitting that wrong button, is imagine being able to do this. So is anybody manufacturing? Can you make something here? No? Only a few. Okay. So imagine being able to look at your distribution centers. So you're making a whole bunch of stuff or selling a whole bunch of stuff. And you've got your inventory. So let's do it in blue here. I'm going to do my inventory levels at this distribution center. So I've got my sales looking pretty good. And now what I can do is this dotted line you're seeing right here is showing the prediction for my next 3 months of inventory levels. And in green, I can do my sales prediction. So right now, I'm looking pretty darn good. I have plenty of inventory levels. But then looks like I'm out of inventory right here. And then I'm looking at way overstocking my sale, my floor. So this can predict, you can compare your projected inventory to your projected sales and make sure you're not overstocking. Get closer to just-in-time inventory. Or your calls coming in compared to your amount of people you have on the floor. Or hospital bed utilization if you're a healthcare company. All those kind of things are great number of contributions coming into your nonprofit. Those are all things that you can always do with time series analysis. Okay, sequence clustering. This is all about predicting the order. If order matters to your company, you're manufacturing something, something's going in a line and a fault is happening here, you can predict it with sequence clustering. Okay? Association rules is Netflix, is Amazon, are those kind of things. If you look at this article, you might like this article also. If you watch this video, you're going to like this video also. A true story about association rules, this is that kind of a data mining folklore now, is they found out, a grocery company we were working with, found out that when people come in at a certain time, it's usually late at night, and they want to buy diapers, they almost always buy beer also. It's true. It's true. That's why you always see the beer in the kids' aisle, in the baby aisle together. It's merchandising know-how. So usually I stick to hard liquor, but it's okay. Now, one of the cool things about this, naive Baynes, is one of those algorithms that's been around since the 1800s. Some of these algorithms are really, really old. Nothing really magic here. If you go to a stats class 100 years ago, you're going to learn about some of these algorithms then. So all these algorithms actually inspired me to go back to a stats class. Believe it or not, I actually went to a math class and dropped out. Anyways, neural networks. Neural networks are the final one. There's also other ones as well. But neural networks is the algorithm that kind of finds very loose affiliations in the data. So someone in Wisconsin is matching the profile of somebody in Florida. That's why I'm not going to give us that credit. Your FICO score, your credit score, is most likely going to be based on something like neural networks. Some guy in Wisconsin is preventing you from getting credit right now, probably, because he defaulted on some loan. So there's also algorithms you can actually plug into here as well. So if you're really a wily C# or VB.NET developer, you can also create your own algorithm and plug it right in. If you go to SQLServerDataMining.com, they have some sample code when it's working. And unfortunately, when the internet, don't go there right now because this is what it looks like. The internet is not very kind right now. I'm going to refresh and see. But this website right here, SQLServerDataMining.com, is run by the product group. And it is, unfortunately, timing out right now because of the internet it passed. But imagine, if you will, an amazing website with flashing graphics and coffee dancing cups. They have a whole bunch of code. So if you think you have the best algorithm for healthcare or for call centers or for whatever, you can build that and have SQL Server do all the heavy lifting for you, and you just do the brain work. So it gives you the bronze behind the brain. All right. So Well, I wouldn't normally show a demo here, but SQLServerDataMining.com is down right now. But if you want to go there, you'll see live samples, and you can download all the code for SQL Server Data Mining also. So they have a call center application. As I'm entering in stuff, it'll flag it as a suspect row or a good row, and it shows you all the queries. All that code is right there for you at SQLServerDataMining.com. And they also have a shopping cart application. But if you buy this product, you're going to buy this product also. There's lots of good stuff there. Okay. So as far as an interface, we're going to use the BIDS environment, the Business Intelligence Development Studio environment. I'm from the South, so I can't talk very fast, so I'll say BIDS for short. We can also use Management Studio to query this data mining algorithm also. So those are our two interfaces that we'll use. Now, as far as integration, where can we use this at? Well, I mentioned before that we reduced that insurance company's lines of code from 100,000 to a couple dozen lines of code. And that's something that happens over and over again. The application starts to learn from your data. So, of course, you can do it in .NET. You'll use ADOMD. It's the object model you'll use to connect to the cube. Connect to the data mining model, excuse me. You can also use integration services. So with SSIS, there's a data mining query task. There's also a data mining query transform. So as data flows through it, you can query the cube, or query the, sorry, keep on saying cube, the data mining algorithm. It can answer the question and keep on going. It can classify your customers. We can also use it in reporting services, or we can build queues based on this. Now, if you want to embed this into your application, it's really, really easy. Again, that's a couple lines of code, really, to do this. It's ADOMD, and the data mining language we'll use is DMX, Data Mining Expression Language. By the time you guys leave here, you'll know basic DMX. It's very, very easy. It's like T-SQL with a few extra words. Okay, and they're all swear words. All right, but the cool thing about this is your application learns. So one of the neat clients we had was looking at comparing, all right, you are in the construction industry, SQLox, and you like these certain kinds of projects, but then the economy tanked. Now, traditionally, I would have to re-architect the application to figure out, new patterns, right, and write do .NET code. Instead, the data starts to prove that you don't like those kind of projects anymore. That you've said prefer green projects, because there's a lot of incentives right now for green projects. So the data learns, the algorithm learns as it retrain it each time automatically and starts to push those to you instead. So that's the cool thing about this. You write the code, you write the algorithm one time, and then you're all done. Don't have to worry about it anymore. Okay. And there's some architecture here as well. Okay. So again, the language is ADOMD, and we'll be using a whole bunch of good stuff here. All right. Here's actually an example of the command object here. Again, it's really 4 lines of code. You pass your query in, you're all done. And I'll show this in an example a little later also. So it'll make a lot more sense. All right. Those are my slides. We're done. Have a great day, guys. Sorry. Oh, I have a few hours left. Okay, so what we're going to do next is we're going to go through a complete end-to-end example. And I'm going to spend the rest of this session doing a demo and focusing on how do we do this. I'll use some data that you all have, so you can actually pretend to do this. You can actually play back the recording later if you wanted to, or try it yourself, and work on it. So, to start, you know what? Let's go back over here. I'm going to open up a BIDS project here. Go to my File, New, and Project. And I'm going to select Analysis Services Project. So, most of you guys raised your hand that you've done a queue before. We're going to be in the same world here. I'm going to call this just pass afternoon and hit enter. Now, to do the demo, I want to make sure I show you how easy this is. That you don't have to just be, a BI super engineer to do any of this stuff, or even a BI person at all. So what I wanted to do was bring up somebody who's never done this before. And I think I have your DBA. Yeah. I spoke with her earlier. Come on up. All right, so give her a hand. This is, what's your name? Kim. Okay. Kim? Kim. Okay, so we met before, actually, but you've never done this before, right? Okay, so Kim is not a plant. I asked her to do this like 30 seconds earlier before I started my session. Can you vouch for me? Okay, yes. All right, so this is not magic here in any way. So what's nice about having Kim do this is I can now walk down and sit down over here. So, Kim, we want to create a new project. I think I've already created a project, and now we'll see in Solution Explorer now a whole bunch of new types of elements here. So can you kind of go over to Solution Explorer on the right? Kim is new into BI, and we want to create a data source. So we're going to right-click on data sources right there, and we'll select File, New, and our data source. There we go. Now, we're going to connect to SQL Server here, but you don't have to have SQL Server. You could connect to Access, God forbid, or Excel, or SQL Server, any of those kind of places. So any kind of OLADB compliant data source we could do. Now, I've already got a connection here to AdventureWorks 2008 R2. I wanted to make sure that people could actually do this, at home also. So let's hit next. Okay, and we'll see a screen right here. This is an important one. So this is asking us, when I go to process this, when I go to retrain this, what account am I going to use to do this? So we ideally want to use some kind of service account, some kind of Windows AD account that's not going to change its password every 2 weeks. That's probably a bad idea, right? So we could do that, but we're going to be lazy right now. We'll select Inherit. In 2005, it's called Default. But the Inherit option is going to use what it thinks is the best security model for what it's doing at the time. So Kim, if you wouldn't mind, hit Inherit and hit Next. So the Inherit option is going to use a service account for doing most of its work, and it's also going to use your account for doing some work also, like drill through or those kind of things. So you'll need to make sure the SQL Server Analysis Services service account has read-only access to your data source. That's the first requirement we just did here. All right, so Kim, would you mind hitting Finish? Okay. Our next step is to create a data source view. This data source view is going to act as an abstraction layer between our underlying data source. So if she goes to File, New, and Data Source, well, she's fast. All right, so she's going to point to that data source she already created. She'll go to Next, and we're going to pick some tables next. So these tables you guys already have. If you have AdventureWorks installed, you have these also. At the very bottom, we'll see a whole bunch of views. So they all begin with V. Just for simplicity, let's add all the V tables, and you can multi-select all those. So you can pick all those and go all the way down. And she's going to pick all those right now. Okay, so this is going to give us a few tables here. We'll go over these tables in a moment. And these tables have a whole bunch of great stuff inside it for data mining. These are all for data mining. But notice these aren't physical tables. These are views, I did no SSIS here to kind of load this data. So if you wouldn't mind, hit Next, and then Finish. She can name it accordingly, give it some better name than this. But she'll hit Finish now. There we go. Wow, that was amazing. Okay, so let's look at the data in this customer table. So first of all, we'll see a V target mail table over here. It looks like a schema, right? It's basically just showing us all the tables. If there's any kind of connections, it would show those also. It's kind of the same steps she would do for a cube. But when she right-clicks on V target mail and does explore data, what we'll be able to see here, V target mail. Yeah, you can do the left there if you like. It's all in the, yeah, there you go, perfect. And you can right-click on that and do explore data. This is going to give you the light data profile that you may need to make sure your data is actually good. So right now we're trying to formulate a hypothesis, right, on who is good and who is bad. So as she does this, would you mind, could you hit Control-1 to zoom? There we go. Wow, okay. So we're seeing a list of all of our customers here and whether they bought a product from us in the past. So this is historical data in this case. So these are all the old stuff that we have in our system. We see they're married, what their birth date is, how old they are, those kind of things. All that metadata about our customers. I think you're in here also, aren't you? So we actually use this internally. We use something like this internally that when you go potentially download our software perhaps, we grade your customer and we assign different values on them, how much we're going to bug you each day. So these are the kind of things you can do in data mining. So if you slide all the way to the right there, you're going to see one more thing. There we go. So all the way to the right, if you zoom in right there, we see a bike buyer flag. And this is showing us in the far right a little bit flag, on or off, of whether the person historically has bought a product from us or not. There's no magic here. This is looking at a transaction table over here, and a customer table over here, and doing a left outer join. Well, this way, doing a left outer join to figure out, or right outer join, I guess, my other example, to figure out which customers actually bought a product or not. So it might be looking at some kind of date pattern of some sort, who actually bought a product from me in the past 6 months, because I want to stop bugging this guy, or whatever. Okay, but that's what it's based on all this metadata, we have that or not. And there's all sorts of good stuff, all sorts of good places you can get that kind of data from if you don't have it right now. So if you have an address, you can get some pretty neat stuff from the US government. So, we actually have a lot of that neat data. That's why I've been stalking you for the past 2 months. So if we go back over here now, we've seen our data. We can also go over to the chart tab right there, and we can see it kind of broken down a little bit differently here. In this case, we're looking at a graphical version of the same data. It picked a few elements here and it's showing us kind of a breakdown of our data. If we have any outliers, we may see it right here as well. Okay? But it looks like all of our data looks pretty good. The word missing is not here. That's the important one. If we see the word missing, it means we have some null data. And if we're planning on using that data for some data analysis like this, we would have some problems. So if you would hit, Kim, the drop-down box right here, she can also add other elements here as well. So she can go through and say, well, let's look at something else interesting. Pick whatever you think is interesting here, Kim. All right, age. And when she clicks away from that right now, English, there you go, and clicks out away from that anywhere, you'll notice it kind of shows a breakdown, kind of a bell curve of our ages. All right, so this is kind of helping us formulate a hypothesis right now. All right, next, that's all there is to data preparation in our case. We build a view. We're kind of lazy today. But we could have done an SSIS package to kind of grab random samples of our customers or whatever. So our next step is to create the mining model. So if you see in Solution Explorer on the right here, you'll see mining structures. And if she right-clicks on mining structure, she can create a brand new one. All right? This wizard is very, very simple. For some reason, I don't know why I think it's a nice little scam that we in BI have, that this is really hard, but it's not really that hard. I'm not going to lie to you. I don't know why they paid me that money for that 20%. But it's really, really easy. And I think you guys can do this as soon as you leave this session. It's that easy. All right, so we'll hit next right now. And the first thing it's asking us, do we want to go against a cube or against a table? We'll go against a table. Hit next. And next it's going to ask us the algorithm. If we had any kind of custom algorithms here right now, we see those in the drop-down list right here. If you would hit the drop-down list there, Kim, and if you hit Control-1 to zoom in. So we see a list of the ones I already showed you a second ago. Decision tree is the default, because it's the most common one you're going to use. In our case, we're trying to classify customers. Who is good, who is bad. That's what we're trying to do right now. So you can hit escape to get out of that. And let's hit next. Okay, where's our data at? Piece of cake. Hit next again. And next it's going to ask us, where is our case table at? And all the case table is basically a table that holds all the evidence that we want to use. Who is good and who is bad. That's all it is. So I have a record in there for every customer. That's all the evidence, all the pile of evidence I have. It could be for every transaction or every call coming in or every sale you have. Whatever it is, it has a primary key on it, and it's saying, here's all the evidence I have, and it has some kind of prediction thing inside of that. Now, in our case, we want to look at that vTarget mail. So we'll check that vTarget mail. Very good. And you'll also see one more column. May I sneak in real quick, Kim? Now, what we want to see here, see the nested column? I mentioned before that the data has to be flat, right? Well, we can break that rule. And this is one of the cool things that Microsoft does that other data providers don't do. Is as far as 2008 going forward, or 2005 going forward, we can actually nest this data. So let's imagine, Kim, you want to start a dating site. Nobody's doing that right now, so I think it's a great market to get into. So there's no people out there. So I've done some really advanced data mining algorithms. I figure it's a good place for you to join. So what we want to do is we'll have some kind of customer ID of some sort. All right, or I guess candidate ID, isn't it? All right, what are the things would we think we would do for a dating site to match person 1 with person 2? Gender, that's probably important. All right. Maybe age, okay. What was it again? Shirt counts. So you're saying that if you have 15 shirts, or if you only have one shirt, you might be homeless. That could be important. That's a good point. Okay. So there could be other things. Could be hopefully things like hobbies also, and we'll stop there. But it could be some religion things or whoever else in here as well. So I've got candidate 1 here, and I'm trying to match him up right now. And I know he's a male. He is 35 years old. He has 2 shirts. Well, actually, he's kind of the queen. He never wears the same shirt twice. So kind of like the queen, right? All right. So now his hobbies, though. Let's see. How about he is walks on the beach. Yeah, on the beach. That'd be good. I like those walks on the beach myself. He said cats. All right, so he likes kittens. He likes, stalking. and other things like that. So, okay, so watching sunsets. Okay, there we go. So we've broken our rule about flattening the data, haven't we? So we have a one-to-many relationship. Actually, it's probably, hopefully, in IT, we have more than one hobby, but it's a many-to-many relationship probably, right? I have hobbies here. I have my candidates here. I can pick lists from them, right? So I have a many-to-many relationship. The only way to implement that is with a nested table. And what it basically does is it puts a little plus sign here, and it stores an array. It cheats data mining. It stores an array of different rows inside that one column. So I hit that plus button, and I'm seeing 15 rows or 10 rows, all kind of faked inside that one column. It puts a table within a table, right? Almost like a, yeah. So that's what nested does. So I said before you had to be flat, but not necessarily. You can break that rule with the nested tables. Make sense? No? Okay, just making sure. All right, so let's hit next. We're going to do that in a second. So actually, you would check multiple tables here. And as long as there was a relationship in the data source, the question was, how do I define a relationship between those tables? First of all, in our data source view, we would have to have lines between those, so keys between them somehow. They could be fake lines. And then as we went through here, we hit nested. It would automatically check that. Yeah, good question. What's your name? Martin. Okay, gotcha. So let's hit next. And this is going to show us a few more things now. Now's our hypothesis time. What makes a good customer and what makes a bad customer, in our case, for buying a bike, in this case. So what we can do, first of all, is we have to check, well, what are we trying to predict? So we're trying to predict that bike buyer column, that 1 and 0 right now. So if you were to go and check bike buyer for predict column. There we go. Now, what do you guys think? What's going to be a good bike buyer? It's one of them. Okay, so age? Okay, so they're 90 years old. They're probably not going to buy a bike from me. Maybe a rascal, maybe. So we'll hit check age. What else? Commute distance. Okay, so if they commute 0 miles to work, bike might be kind of cool. Okay, and now we're guessing right now, right? We have a hypothesis. This is a great time for a BA to come to your desk and actually say, I think this is the golden rule. But if we don't know, then we could hit the suggest button at the bottom. Now, the suggest button at the bottom is going to run some light data mining algorithms to guess what is good and what is bad. It's trying to find correlations in this data. So if we go through that and we hit the suggest button at the bottom, Kim, it's going to run those mathematical algorithms and come back with some light answers. So would you mind zooming in there? Control-1 to zoom. Okay, there we go. So it thought number of cars owned, if you have 0 cars or you're driving your mom's car, it's probably a good idea to get a bike. Okay, probably. We also can see that total children. If you have 4 children at home, like myself, you probably can't afford a bike. All those kind of things can be decided right here. So what Kim can do is she can actually check those as inputs. And we're seeing the correlation here. Number of cars owned. There's that much correlation between that and that flag 0 or 1. It doesn't have to be a 0 or 1 flag. It could be male, female, or good customer, bad customer, high value customer, good value, low value customer. So if you zoom out right now, you can check a few of those. Let's do number of cars owned. You can actually check them right there. Go back to suggest again. Yeah, could suggest, yep. And you can check them right here. You sure can. But wait, there's more. You're now featuring checkboxes. All right, so we'll go to children maybe. How about English education? No? You don't think people that are well educated can ride a bike? It actually says, so to his point, it found a correlation between French, Spanish, and English education. There's words to it. It doesn't know that bachelor degree is a bachelor degree. It thinks it's a word. It sees correlation there. So we could check any language we wanted to here. Somebody said commute distance earlier, so let's check that. And let's also check yearly income. There's a few there. Okay, so we checked a few of those, and we can always add more later. This is a good part. What's that? Middle name. The little fact that people that have a middle name of Rockstar typically have bikes because they can't afford any car. All right, so we hit next. All right, so I didn't say it was always going to suggest right answers, but at least it... So what we're seeing right now, would you mind zooming in here also? So this is going to show us what type of data are we storing inside this. So we're seeing, first of all, on the far right, long. Long is a number. String, of course, or text is a string of some sort. And we also see double as some kind of numerical value of some sort. But also on top of that, we're seeing content type. What type of content is stored inside that string data? So content, let's see. We've got continuous values and discrete values. So think about it this way. If you can put that value in a drop-down box, it's probably going to be discrete value. So translated to English, it probably makes sense. Like genders, maybe states, you can put those in discrete values, right? Countries, those kind of things. However, continuous values mean a number of some sort, where the fact that you have one child and I have 15 children in a TLC special is completely relevant in this case, right? That my patterns of buying are going to be different than your patterns of buying because you have 1 and I have 15. It doesn't care what that 1 and 15 is. It just knows the distance between 1 and 15 matter. Or the fact that you make $20,000 a year and I make $1,000 a year is a significant difference also. So it's a number, but it's not just a number. It's a distance between those matters. That's what continuous values mean. And there are some other ones also. We can also do something called discretization. I love that one. Discretize. What that means is basically put numbers in buckets. I make $0 to $20,000. You make $20 to $40,000. And it basically puts those numbers in big, big buckets there. So if we go in here and let's hit escape and let's hit the suggest button, we can guess. It's guessing right now. But if we hit detect, it's actually going to look at that data and find it. I have a question right here. Because it guessed wrong. It guessed it based on data type right now. But if she hits just to detect right now, it actually is a discrete value because they've already bucketed things. They put 0 to 5, 5 to 10 miles, and so on and so on. That's a great question. That's why it's a discrete value. There's only like 8 or 9 values. But if I actually had the exact number, then it would probably matter in that case. It probably should be a continuous value. Any question over here?
Yeah, on the screen before this, I hate to go back, I was just going to ask a question. On the screen before this, it recommended some predictor variables.
Mm-hmm.
And I'm just wondering why you wouldn't have picked all the top ones if it was recommending them or suggesting them as good predictor variables.
Okay, so, yeah, and what's your name? Eugene. So Eugene's question was, why don't we go on the back screen and just check everything? Well, it's going to slow the data mining algorithm down, and we can also add more later. There's a lot of trial and error we'll find to this. We'll try it and see, is the model guessing the right thing? Let's add 2 more columns. Did that hurt us or help us? Is it steering it down the wrong path? So you can actually have too many variables in there, too, and it confuses the data mining model. In our case, I'm going to show you how to add more in a second. So it's completely a tutorial thing, just to kind of show how to add more later. Okay. Good question, Eugene. Yes, sir?
Is there any way to time
No.
slice it?
Okay, sorry. Any way to time slice?
Like to time slice it so that you start your data model and you look at your existing data up to, say, a year ago.
Okay.
Do your prediction, and then compare it to what the actual data was after the end of the year.
And it's Clinton?
Woody.
Woody. Okay, so Woody's question was, he sees that in his world, and where do you work? Consumer source. The patterns have drastically changed in the past year or 2 years when they... Okay, so we could have...
Compare your predictions to the actualities of what happens. Therefore, you can fine-tune what your predictions should be.
Right. So in 2008, they have this thing called a filter, which we'll apply later, and the models can steer different ways based on whatever filter you want. So how good is my model at predicting Wisconsin sales versus Florida sales, or 2009 versus 2008? You can absolutely do that. Or you can also control the table. You can actually load only a certain amount of records in the table also. Good question, Woody. Sorry. All right. So we can hit next now. Any other questions? Yes, sir.
For example, like bike buyer is a big, right? It shouldn't be confused. And if we know, like, what's the data content, can we just manually set the content type, or is it just...
Yes, we can absolutely. So the question was, can I manually change this later? We can absolutely manually change this. It's just right now it's choosing the way it is. Did we hit detect yet?
No.
I guess we'll hit detect. It's going to decide. It read the data, and it decided this is the best way. But she can also hit the drop-down box on any of those columns and change them now or change them later also. Good question. Anything else? You guys are full of good questions. I'm sorry? Sure, hit the drop-down box there. There we go. And let's zoom in right there. I will cover that a little bit later. So if you can hold up for just a second, we'll show that one. Yep. All right, so let's hit next. different algorithm, but not really applicable to this one. So this is an important screen in 2008 only. It does not exist in 2005. So imagine going back to high school science again. And in high school science, before you made that prediction, before you actually proved that theory, you had a control group. Or they're back to at least the proper way of doing science, right? So if you had that control group, these are some records that you're going to, or some people that you're going to kind of set aside and to give them placebos, right? Or just have fun with them and say bad things to them. Anyways, so our control group in this case are going to be 30% of our records, what Kim has selected right now. We're going to take 30% of that history and put it in our back pocket. And we're going to use this to test with later. If you're not running O8, you would have to do this manually. You randomly select some historical records and you put them into a separate table. That's how you would do it in the past. But in 2008, it makes it a lot easier. To me, I think 20% probably good enough for our data set. It's a very subjective number. It's somewhere between 10% and 30% probably. It all depends on what you have. We can also say, I want a certain amount of rows down below as well. So take 20%, but no more than 500,000 records or whatever. But that's good enough. Let's hit next. We're going to see this again in a moment. Those are the records we're putting in our back pocket. Just keep in mind that back pocket. It's not going to use that back pocket records to train in this data with. Now that we have that, we're done. Believe it or not, our wizard's done. So let's call this spam. Welcome to my world. You probably got many of my spams to you. Let's call this spam right here. And then next below, let's call this DT. So in a second, would you mind zooming in as soon as you check that box right there? Okay. So what Kim is showing us here is we're creating a structure called spam. And it's going to have a whole bunch of different ways of solving that problem. But our ultimate problem is, who am I going to do a mailing campaign to? Okay? Below that, DT is our structure. This is basically, sorry, a model, excuse me. This model is the brains. What kind of brains am I going to use to answer that question? Who is good and who is bad? And I could pick a lot of different brains. This is just the first one I'm doing. Okay? But this is the algorithm that's going to be used. This is decision tree. I did shorthand here, DT, just so I know what model it is. She's also allowing drill through. And by allowing drill through, this is going to say, well, I found some really rich customers here. I can right-click on those and find out exactly who those customers are. I can do this in Visio, Excel, or other clients also, or DMX. We'll show that in a second also. So let's zoom out here. What's up? All right, let's hit finish. All right, so Kim has now finished the model, and we're seeing our schema right here. This is our data source view on the right, and on the left are our different columns. So if all of a sudden she thinks that marital status is a really big deal, what she can do is she can look on the right there, our middle name. We think middle name is going to be a big deal. So we can drag over marital status down below there, Kim, to the left side. So people that are married, probably want to ride a bike away from their spouses. So she can drag that over and drop it right there, and now she has a new column as selected. Okay, so this is how we can modify things later. So there's a lot of playing here. Typically these projects, as you're doing this prototype, you can knock a prototype out in a week, 3 days probably. But then the actual getting it production time, maybe about 3 to 4 weeks. You're playing, you're adding more elements. I need some data from this data source right here, and you're kind of acting as a mad scientist, kind of stirring it all in the stew and figuring out what you have. That's a data mining project's really a lot of trial and error and trying to figure out the right thing. But you'll be able to quantify the right thing in a moment here. Okay? So, our next step, and to your question earlier also, when she selects this column, marital status, in the properties pane on the right, she can specify what kind of data element is after the fact also. So if you go to properties, you'll see discrete right there. We can change that at any time. And there's lots of other things we can change here as well. We'll cover it later. All right. You guys excited? This is going to be awesome. Yes? What cannot be changed? Okay.
State where you can have multiple statuses, right? Instead of buying a bike, it's just sold interest or something like that. Right?
We can have multiple states. We don't have to have a bit field. It could be mildly interested, really interested, stalking me, and not interested in all. We have all the different states. We can actually I can predict what state you're from. Florida, Georgia, Alabama, whatever, or none of the above. So we can do that as well. So don't think of it data mining just as a bit column. It could be, it's a classification project. I'm trying to classify some kind of element here. But is that your question?
Yep.
Okay, cool. Any other questions? Yes, sir.
Regarding the selection of the columns, you kind of showed like correlation efficiency. Does it have any tool to suggest these are the columns more correlated to these columns?
We're going to see that in a second. So the question was, how can I look at how these columns all correlate? And yeah, can I hold your question until a few moments? Okay, no problem. Any other questions? All right. Yes, ma'am. Great question. Can it handle null data? It can absolutely handle null data, but you may not get the answer that you want because you don't control the answer. So null may mean different things to different people. It might mean the person didn't answer the question. It might mean $0 they actually make. So you want to control that answer. So put the word unknown in there or 0 in there or whatever you think is appropriate. So yes, it can handle it, though. We'll actually put the word missing there instead. Okay? Great questions. All right, so Kim, is your legs getting tired yet? Nope. Okay, good. You're a trooper. Let's go to the next tab over, Mining Model tab. So the Mining Model tab is where all the brain work happens. This is where we define, okay, this is the algorithm. Now notice the marital status in this case is set to ignore right now. Because we dragged it over, but it doesn't know what that means yet. So would you mind zooming in there so everybody can see that in the back? The cheap seats? We have plenty of seats in the front. I don't throw things. It's like Gallagher. I'm going to throw things at you eventually. All right, so if we hit the drop-down box here, you'll see ignore right now, but we could change it to input. We could try to predict multiple things. Back to your question originally. We could predict, yes, they're a bike buyer, and yes, they live in this state, and they're a male. We could predict all three of those things all within the same model right here. We also see right now we're predict only. We're not using bike buyer as other things as inputs also. So one thing she can do, she's going to change that to input, and that's how we add that extra input. But what's neat about this, we can zoom out now and hit, and it's just like the input there for that. So what's neat about this is we can actually add other algorithms also. So as we go through and we say, all right, this one looks good. Let's pit this one up against association rules or neural networks or whatever. She can right-click right in that white space and let's add another model. Okay. New model. New mining model. Sorry. Okay, when she says new mining model, let's call this one CL for clustering. Even though this is going to be completely inappropriate for what this decision is, we're going to try it and see what happens. So she'll say CL here, and she'll click Microsoft Clustering in this case. And hit OK. All right, so Kim, let's do one more of your choice. Pick one, any one. Create a model that you like. All right, let's see what she does. I'm going to turn it back to her and see what she's going to throw me a curveball. Okay, so don't pick the Brian algorithm. Okay, so, and this gives some kind of alias of some sort. So there's some that are appropriate, and there's some that are inappropriate, and it's okay. We're going to measure them against each other and try to analyze which one is actually going to work better in a second here. So notice she selected what you select there. Association rules? So if you would zoom in there, it's a great error message. So this warning message is telling her that some algorithms, association rules in this case, cannot handle continuous data. And there's some that can't handle the other type of data. So there's some that are specialized for certain types of elements. In this case, it's going to say, I'm going to have to drop that. I can't handle the age column and the yearly income column. So if she hits yes right now, it's going to drop those two elements. That's fine. Hit yes. There we go. So we're set to ignore on those two columns now. All right. Savvy? All right. So let's go ahead now and deploy this to production by going to Build and deploy pass something to production. Okay, so right now it is deploying this to our analysis services server. We did not have to have SQL Server to do this, just analysis services somewhere in our environment. It is also running a whole bunch of algorithms. It's reading the data, and we can actually see the queries that are being run right now. These are very, very standard algorithms. And Microsoft puts a slight slant on these, though. So we'll see decision tree plus a little bit of extra stuff, a little oomph to it. A common question I get asked is, how does this compare to SAS? Okay? Probably a lot of questions here about that. Now, SAS is a great tool. They specialize in data mining. And this is probably 80, 90% of what SAS can do. So it's missing some knobs and some specialized kind of things that SAS can do really, really well. But you're already paying for this. You already own this today, where other tools might cost you hundreds of thousands of dollars. So that's the main difference between this and other platforms is a couple $100,000 or millions of dollars. All right, so what we want to do now, we've got our model now there. I want to now figure out, what does this actually look like? What are the correlations between my columns? So if we go to the Mining Model Viewer tab, the next tab over, just going to walk through them one by one. So what we're seeing right now is a decision tree model showing us, why is this customer good? And picture that yes-no question. So right now, if we select all, on the right, would you mind zooming in over here? So on the right, we're seeing with all of our customers, 14,788 customers, it looks like we got about an even breakdown historically of people that bought products and people that did not buy products. Most companies would be very, very happy with that number. That's probably not your state. Mine's like 10%, probably 12%. So it depends on your environment, but this is basically showing us a breakdown. So let's zoom out there. Now, we really care about people that are actually buying products from us in our case. So let's try to explore this data. Now, this viewer that we're looking at is a free viewer that you can actually embed into your application. It's a .NET control. So you can actually just have this in your web page or your WinForm application. It's all right there. Now, the cool thing about this, you can download it from the part of the feature pack, by the way. The SQL Server 2008 feature pack actually has this viewer right there. If you do that, this is your secret sauce now, though, right? So you may not want to show it. You can also tap into this with Excel and Visio, and your BAs can print out this big plotter graph about who is good and who is bad. And she put it on their cube wall. Okay, but let's do this. Let's figure out who's actually going to buy a product. If we hit the drop-down box where it says background right there, if you mind select one, then just zoom in and show people how you did that. So the background option up top is saying, let's really focus on just the people with the behavior I want to select. So she selected one right there. So now the darker the color blue, the bigger the chance of somebody buying a product. Those are the best focuses of my product. So as we see that dark blue in that mid right there, looks like people, first of all, we kind of follow the branch. People that are 34 years old to 42 years old and have no cars at home. So we can select that no cars at home right there. Now this is going to give us a where clause that we can see. So let's look at that. So Kim, it looks like if we zoom in right here, starting here, you got to zoom it thing down, don't you? There's our where clause. And as she zooms in, I'll go a little higher, we can see that we had 1,700 people, roughly, that fit that criteria. And 71% of those people actually bought a product from me. Okay, that's interesting. So if somebody came in tomorrow that was that age and had no cars at home, I should start to majorly promote my products. So let's zoom out there. And let's kind of slide to the right here. Let's figure out more. 70% is pretty darn good, but let's hit the plus button next to that customer. All right, so she hit the plus button. It's getting better. Oh. All right, now we're really narrowing down. Now they're 37 to 40 years old. I shaved a few years off. Now there is an 84% chance by losing those few customers that they're going to buy a product from me. Getting closer. Let's go deeper. There we go. Hit the plus button again. Let's see. This is groovy, isn't it? Let's go to the right again. Oh, your sales guys are going to drool right now. Look at that. All right, see that red color right there? That's the percentage chance you're going to buy a product, and it looks like there's a 96% chance of the 254 people that met that criteria, 96% of them bought products. So who in the world are these people? Because I need to start to really spam these people. So what we can do to find out who they are right now, because we turned on drill through, one thing Kim can do is she can right-click on that, and she can say, show me those customers. Drill through, and let's see the model columns. There we go. It's fine. There we go. And we're just exploring. This is kind of a BA role right here, right? We're kind of exploring, trying to figure out who is good and who is bad. Pretty cool. So we're seeing all that data now, and I selected only the model columns, but I could actually select all the data from that table as well. Yes, ma'am? What's that again, please? Right. Oh, great question. So how can I tie into this from Excel? You have to use a plugin to do that. It's 2007 only right now. Right. So you'd have to use a data mining add-in. Unless we took this data and put it into a cube, at that point we can actually expose it through just a regular pivot table. So great question. All right. So let's go ahead and close this. I missed your name. What was your name? Helen. Helen? Okay. Easy enough. So let's close that. All right, this is just one of the viewers. There are actually more viewers than this. If we hit the drop-down box right here, we're going to blow their mind. All right, so the drop-down box right here says tree viewer and, decision tree, excuse me. Oh, and also, back to your question originally also, before we leave this, let's go to that, can you close out that? Let's hit the dependency network. Let's blow their minds. All right, so we're seeing, now this is not that interesting this time, but if we had lots and lots of columns, we're going to see the heavy influencers right here. And as we kind of slide this bar down, we'll see what impacts somebody buying a product the most. You'll see that those lines start dropping off. Interesting. Now, if we had association rules, back to your question earlier, we would see lines interconnecting like a web. That this column affects this column, and if I have this kind of data in the column, it affects this one. It's a really, really cool model. So age is the biggest influencer. And we can, of course, copy. There's a copy and paste button right here to copy the image into Word docs or whatever. Okay? But let's go hit the drop-down box for the decision tree. Let's try clustering this time. Now, clustering is not appropriate for this model. I just want to show you the model a little bit. And we're seeing different pockets. Would you mind zooming in there a little bit? We're seeing how all these different pockets of my customers relate to each other. So this farmer in Wisconsin is like a farmer in the Southeast, potentially. So those are the kind of things we can do with clustering here. Now we can actually see those customers if we can actually drill through the customers and see what actually the cluster 8 looks like. So if we really want to see what cluster 8 looks like, let's actually go in cluster 7 or whatever. We can select cluster profiles, and we can get a breakdown of those clusters right now. Okay? Oh, you can close that. That's fine. So we're seeing all the clusters and what kind of data it holds. Again, not appropriate for this kind of data. But I just want to kind of show you this browser's here, right here. Okay? Now, Kim and I think that we have a pretty groovy model right now. So we want to do some stuff with it. To do that, we want to test. Just because we think we have a good model doesn't mean it's actually a good model, does it? So what we want to do is we're going to compare all these algorithms to see how good or how bad are they. And to do that, we're going to go up to the mining accuracy chart. And this is the most confusing part of data mining just because it's a little bit interesting at first. So let's imagine how we can do this. What we're going to do is we want to see how good is this model at predicting you're going to buy a bike. So the behavior I want to predict here, predict value, right there, so on the right column here, is predict value. Oh, sorry, go back over again. It's all right. Right here. So she's going to change that predict value to 1. That's what I'm trying to predict. It may be just important to predict 0, really. All right? And we can also filter it at this point. Filter it to just 2008 data. Mr. Woody, I'm sorry. You threw me off. All right, sorry. So we can now say how good is a model at predicting bike buying patterns in Wisconsin. All right, now that we have that done, let's go, first of all, to the classification matrix. Remember that model before I said I put those 30% of my rows or 20% of my rows in my back pocket? Well, now, I think the student's pretty smart. I'm going to take those 20% of those rows out and quiz it. And I say, well, I know the behavior right here already. I already know the answer because I already know this person bought a product or not. And I'm going to ask it 3,000 questions. I have this person who has a red sweater who's really smart. Is he going to buy a product from me or not? No. Oh, okay. Well, let's try it again. And you're wrong this time. You're right this time. This classification matrix tab right there, if you go there, will tell us how accurate are we. So may I drive for a quick second? So what it's going to show you is for the decision tree right here, when we predicted you're not going to buy a bike, we were right 1,300 times, and we were wrong, looks like 500 times. So overwhelmingly, we were right. Okay? Not what my wife tells me, but when we predicted yes, you're going to buy a bike, we'll say you're right 1,200 times, and you're wrong 450 times. So this is giving you quantifiable evidence on how right or wrong are you. Can you get false positive and positive falses? You could, but in this case you can't. This is telling us absolutely, this is historical data it's looking at. This is actually saying historically you're right or wrong based on the records you held back. So this is called a testing set, by the way. It's data you hold back and you use it to see how good and bad are you. Our next step is to go to this lift chart. You're driving again. And in our lift chart, what this is going to show is more graphically how right and wrong are we. So let's imagine that Kim's marketing department got cut by 50%. And she's only got to market to the right people. All right, well, let's see how this works. That blue line right there is a random guess. I'm going to toss a coin, and you're going to buy a product, you're not going to buy a product. You're going to buy a product, you're not going to buy a product, and so on, and so on, and so on, and so on, and so on. A random guess is the blue line. So hopefully, my model's better than a random guess, okay? The red line is perfection. So based on history here, what we're seeing on the bottom right there is 100% of my customers. Okay, so let's imagine I have 100,000 customers, and my marketing budget slashed by 50%. All right. The vertical axis is how many of those 100,000 customers actually bought a product. Okay, so what that means is Kim right now, if you move that mouse, click somewhere in that graph right there, you'll see that vertical bar as she clicks, as she moves. Now, what we're seeing right now is she's about 20%, or 20,000 of our 100,000 customers. And we're seeing 19.2%. Would you mind zooming in over there? So with 19% of the customers selected, I'm marketing to only 20% of them right now. Our perfect model was able to get 37% of our bike buyers. If I always knew the answer by marketing to only 20% of my customers, I'm getting 37% of the bike buyers. I never was wrong in this case. It's perfection. However, random guess is 19%, not very good. Association rules is getting, by marketing to 19%, is getting 27% of my overall bike buyers. Not bad. Better than not. Decision tree is 33%. So it looks like decision tree is winning right now. If she selects 50%, because I have a 50% budget right now, how do we do? All right, we select 50%. This is called a lift chart, by the way. And if we look at this, it's telling us how accurate our model is. So in this time, at 50%, by marketing to 50% of my customers, I got 87% accuracy. It's 87% of my actual bike buyers by cutting my budget by half. I'm still getting 87% of the results. Not bad. But association rules is only 77% of results. Woody? Oh, the ideal model is perfection. Like I knew the answer key already. So I knew before I even asked you if you're going to buy a product or not. That you must use a telepathy component to do that. So unfortunately, it does not work. We're still working on that one. Okay, so you can escape there. All right, so good question now. So the ideal model is I already know the answer 100% all the time. I mean, that's not gonna happen. This is interesting, but my marketing department really cares about what if scenario. How much money am I actually going to make on this darn thing? So if we hit the drop-down box where it says lift chart, we can change that drop-down box to profit instead. How much money am I going to make? That's what they really care about, right? Oh, there's a question over here? Yeah, so I sound really bad. There's a control we can use in .NET to actually expose this. Also, the same thing that we're looking at right now is exposed through Excel plugin. The .NET control works on web or win. So it's up to you.
I have one more question. So in this data mining process, we just consume one specific data set.
Mm-hmm.
And if I want to work with data mining between two different data sets,
Okay.
but there are no relationships, so that's the real-time scenario, do we actually do it in the DSV?
So the question is, I have two data sets that may or may not have correlation. They have no keys to join them. Okay, so you have to do it in data source view somehow. You have to find some way, some compound key to kind of bring them together somehow. Or data source view, or a SQL Server view, or ETL has to do it. Okay? But something has to join them. Way in the back. Thank you, Kim. In the cheap seats. Okay.
So in that situation, how does this
So can you repeat the question one more time, please?
more likely you have who are the customers who bought from
Right.
the product than a zeros and who did not buy.
Right.
So in that situation, how does this entire scheme?
Well, what's going to happen, so the question is, and more than likely, you just have customers actually bought from you, right? Well, most cases, I have, for example, in my CRM, my customer relationship management tool, we have a whole bunch of leads, and we have a whole bunch of opportunities. So the leads convert into opportunities eventually because they actually bought a product. So I might have 80,000 leads, but only 5 of them actually turn into customers. That's what more is real. That's what we do personally. Is that your question? Okay. All right. So that's an interesting one. So what the real world does typically in that scenario, let's say I'm Amazon, for example, and I have a whole bunch of customers already. They're already customers. I don't have customers that aren't customers. But what I might do is I might mail them a coupon or email them with some spam, and I want to see if they actually responded to that. I embed some kind of code to see if they actually are going to respond to that. That's what most companies do. Is when they mail you a coupon for 5% off your oil change, there's a code on that. I actually worked on that code. And it actually will translate. As soon as you do that, I'm going to start mailing you more spam. So that's how most companies, they do a coupon of some sort or some kind of tracking device to see if you come back and respond to the campaign. Okay? But if you've been an Amazon customer before, you probably get emails once a week from them, right? Saying, try this book. And they're constantly logging if I responded to that campaign or not. So it's always my books. Yes. I'm the only one that actually buys those things. All right, so in this case, would you mind zooming in here? So in this case, wow. Yeah, we are going to market to 50,000 customers. We have a fixed cost of $5,000. To do this campaign, it's going to cost me $5,000 of layout fees and all those kind of things. But for each campaign that I mail out, it'll cost me $3. So every brochure I mail people, I might put a coupon in there. Maybe I'll up that to $7. Let's try that. Let's up that to $7. Yeah, it's the individual cost. Yeah. So we're going to make this a high-risk campaign. We'll put that at $7 or $8, whatever you want. But we can make $15. I should probably be fired for doing this campaign, probably already. But if we hit OK right now, it's going to let us know how much money we'll make or lose from this campaign. It looks like we stand to potentially make some money. With Decision Tree, by marketing to 50% of our customers, we're going to make $90,000 in the top right. I think it's $90,000 up in the top right there. Looks like $90,000 up in the top right. So it's actually quantifying how much money you can make, win, or lose here. Okay? So we've proven that Decision Tree is probably the best model here. So from this point, yes, sir? It's a great question. So can I do this with just how many calls or can call them a call center perhaps? It's going to put dollar fines on that. So there's a profit kind of calculation. Yeah, great question. All right, so we can do it in DMX though. So we can do it there. So if we cancel this out, all right, and let's go to actually write our first query now. We think that we want to market to 50% of our customers. So if we go to the Mining Model Prediction tab on the top right, there we go. Now, I've got some new customers that I've never seen before. This same UI we're seeing right here is also in reporting services. And all you just click the cube and you'll hit the data mining button and it opens up the same UI. It's also in SSIS as well, in the data mining query transform and data mining query task. The same exact UI. And the goal of what Kim's going to do is she has brand new customers that she's never seen, that marketing has loaded into a table. And she wants to see, are these people going to buy a product or not? I'm going to grade these customers. So let's go to select case table. And notice on the left here we're using Decision Tree. But we can pick different algorithms also. We're going to focus on Decision Tree. And I've got a table right here I created earlier. It's called V Potential Customers. These are customers that are brand spanking new that I've never seen before. Looks like they've mapped up. So notice there's no bike buyer flag on the right. I have no idea if they're going to buy a product. Looks good to me. All right, so now I'm basically building a query old-fashioned designer style. So on the right, I'm going to double-click what information I want about these customers. So maybe I want to get their address to spam. So I'll double-click on address on the right. There we go. Double-click it. Yeah, and it puts it down below. And I can add a few more, maybe their age or whatever else you want to put. That's fine. All right. On the left, though, I want to know, are they going to buy a bike or not? So I'll double-click on that column on the left. It's a little diamond-looking thing right there. So now it's going to pass each of those new customers in and give me a yes/no answer. Are they going to buy a product? Next, I want to know how much are they going to buy a product from me. So from the drop-down box right here, we're going to see a column called prediction function. And in this prediction function, we can write some DMX to figure out how likely are they to buy a product. So in the drop-down box next to it, we'll see isNode. there's a whole bunch of really cool DMX functions, mathematical functions we can use. We can see things like predict probability, standard deviation, give a histogram of how the customer actually is. All those kind of things you guys keep asking questions about, we can do right here. Predict probability is something we can use to say how accurate is this record, those kind of things. But let's go ahead and say predict probability this time. This is pretty cool stuff, isn't it, guys? All right. All right, let's go there. Now, predict the probability of what? I want to predict the probability of them buying a product, right? So if we drag down bike buyer from the top left into that which is scalar column on the bottom right, that's what we're trying to predict the probability of. What is the probability of that column, right? What's the scalar column on the far right?
Oh, I see.
There you go. And it's released right there. So what is the likeliness of that column right there being the value of 1, or male, or female, or West Coast, East Coast, whatever? So if she types the comma right after that right there, perfect, comma, 1. What is the likeliness of this column being 1? Now, you have written DMX. Very good. Give me a high five. That's awesome. All right, so.
That's for me because I'm a DBA.
And she's a DBA, guys. All right, so let's go and hit this. I'm a DBA too. It's okay. I can say that joke because I'm a DBA. All right, so let's go over here and hit this button right here. And let's zoom in on the responses here. So it looks like, if you zoom in there, we're seeing the information, address line 1, she's a 41-year-old, there, and whether the person's going to buy a bike or not. And if you all the way to the right, we can see, the percentage chance of them buying a bike, 95%. Sign me up. Great customer. Now, again, I could do this in reporting services also. This could be a report that marketing can receive every morning on who to call every morning. And if I zoom out again, I can also save the table right here as well. But I really want to order this. I may want to put a where clause on this also. Yes, sir? How can probability be more than 1? Where do you see that? Okay, so that is a good question. May I zoom in real quick on this? Okay, so the question he has is how can probability be more than 1? If you see right there, it's actually a very, very low percentage chance. Yes. You're not going to buy a product. You're really not going to buy a product. Okay, so what we want to do now is we're going to continue writing some DMX. So if I go over to here again, I'm going to hit the drop-down box, and we're going to write a query here. Now, this is the query that we see right here. It's not that bad. It looks like T-SQL, doesn't it? Select the columns, do a join, but rather than doing a join, it's doing a prediction join. You can learn DMX, I swear to you, in a day. It's not like MDX. It's not that bad. Okay, unless you're a DBA. Okay, okay. Anyways, I'm just teasing. Okay, so what we want to do is we want to copy that one line out. I want to put the best customers up top. So let's grab that line right there, that predict probability. Yeah, the whole line. Yeah. Okay. And if we copy that line, and all the way at the very bottom, go scroll down. There you go. See the join statement? Not bad, right? Look, it feels like T-SQL. We're going to paste that. We're going to do an order by clause all the way to the very last line down. Okay, so right after that, right there, let's do an order by clause. Yeah, so order by and that column name. Order by. So it looks like T-SQL. It feels like T-SQL. All those kind of things all work. Yes, sir?
Do we assume that these two tables have the same schema?
They don't have to have the same schema. All they have to do is have some kind of mapping of some sort between them.
If some of the columns are missing in the potential customer,
Yep.
it's just out from the calculation algorithm?
It'll actually show as missing that data. Okay, so the question was, what if I'm missing data or don't have that column altogether? If I'm missing a gender, for example, it would alleviate that from the mining model. Now, how accurate the model becomes at that point may be in question. Okay? So, if she hits that results button again up top, it'll run it. You're right there. Let's do it. And now we're getting the best customers up top. Oh, well, we do the order by ascending versus descending. But you get the idea, right? It's pretty amazing. Amazing! All right, so we have one more thing to do real quick, and that I want to build an application that's going to pass not all the customers in, but just one customer in, and qualify that one customer in my application. So this time, I'm going to click this little singleton button right here, and let's imagine that I've got a customer who is 45 years old. I don't know if they're a bike buyer. Commutes 2 to 5 miles. See that missing right there? That would be I'm missing the data. Back to your question. Has a partial high school. This person's going to be from my hometown. Married with no cars at home, total children. We'll give him 5 children and yearly income of $12,000. All right. And again, I want to know what's the probability of this person buying a bike? Prediction function.
Stealing one, maybe.
Maybe stealing a bike? Yeah. Hey, the jokes are my bit. You can't, don't go. All right, so I'm doing the same exact query again. I'll hit this button right here and see what we have. There's only a 12%, 13% chance this person is going to buy a product from us. So you can also pass in singleton queries. And if you look at this in this case, the query, it actually shows static values going in this time. So you can do either way. So first of all, I've got a few minutes left. Great job, Kim.
Thanks.
I have actually a book for you. Great job. It's signed by all the authors. Yep, so come by our booth later. Great job. All right, so I want to show you one quick more algorithm that we can that you guys can all use today. And this is one of my favorite ones because it's a great little starter one. So this one is a time series analysis. The reason I say you all can use it is because it's going to predict future sales and those kind of things. Yes, sir. Oh, so the question was, why did I use bike buyer here? Well, what I did back here was I wanted to predict the probability. Right, because I want to predict the probability of that bike buyer flag being 1. So the reason I used it was because over here, I didn't actually pass it in. I'm saying, give me the answer. So if I use the left here, it's the prediction function. On the right is actually my actual data. So notice right here, I didn't put bike buyer in there. Okay, does that answer your question? I can't predict age because it's not a predictor. I didn't actually set it as a predictor earlier. Right. Okay. Yeah, so you would predict the value of that product, in this case, being... Right. In that case, we have a lot of options. One option is predict histogram, and it'll say, here are the 15, there's a 20% chance that they're male, there's a 10% chance that they're female, and there's a 70% chance that they're other. So it will actually give you every single row, it'll give you the whole set of what they might do. That's one way. The other way is you could pass in a product and say, what is the odds of them buying this product also? And I can get into more detail if you like in a second also. Okay? But let me finish up this one quick example real quick, and we will answer some more questions. So I've got 5 minutes left. Let's see if we can build this. All right, so what I want to do is I want to predict my sales next year. This time, what algorithm should I use? Time series, you nailed it. Nailed it. All right, so let's go back over here. All right, so this screen looks all the same. The only difference this time is I want to predict my sales for each of my products. So I'm going to check the predictor this time, going to be my quantity of sales, and how about my amount of sales as well. My inputs, though, my key is going to be the region and the time index. The time index is my year-month combo, or my day combo, or whatever. So in other words, how many of these widgets I'm going to sell in Northeast, Europe, Jacksonville, whatever. So when I hit next, I'm just going to buzz this wizard. Not doing anything in particular here. I'm going to type TS here for time series and hit finish. All right, so we are all done. Let me deploy this, and let me show you how we can query this. We can, of course, query it the other way. This time, though, I'm going to up the ante. I'm going to open up Management Studio and go to Analysis Services. I almost look like a DBA, don't I? All right, so if I go over to my past afternoon, I'm going to write a new query. That's going to hurt my ratings, isn't it? I'm sorry. All right, don't forget to do an eval. Don't mention I made fun of DBAs, because I'm a DBA. All right, so, it's now deployed. And let me write a DMX query against this. So this can be a really quick query. And notice there's no little builder here for this. I'm going to write the old-fashioned way. Oops, that's the wrong algorithm. Here we go. All right, so I want to look at my time series analysis. I'll do a select statement. I'll zoom in a second here. There we go. Okay. And what I want to do is I want to select, how about my amount? I'll stop here. Select my amount and even my quantity. Nah, I don't have enough time. Let's do amount. From TS. Now, if I do just run TS here, you'll see all the historical data underneath it. But I also want to get maybe some other things as well. Let's get, how about the model region? Okay, good enough. And let's try to find out how my sales are going to be in the future. So let's predict, this case, predict time series is a function we'll use. I'll pass that number in and do, oops, come on, and try to predict, let's say, how about 6 months in the future here. When I run it this time, look what happens. So for Europe here, for that product here, M200, now my data ends in 2008 here in this case. But if you had data ended in 2011, it would actually show you October, November, December. My data ends here. But we're seeing 6 months in the future what my sales will look like. Now, as you may know, reporting services can't consume an array like this, can it? It can't just take this data and shove it into it. So what we want to do is we want to flatten that somehow. So if I type the word flattened in front and run it again, there we go. There's your bar chart. So, or there's your line graph, right? So you can see now the history, and you union it with the future, and now you're able to get what your sales should be. How much quota should your sales guy have next year based on some real math, not just on some, pie in the sky hope. All right, guys. I've got a couple minutes here, but I hope you guys enjoyed this. I'm going to answer some questions also. Yes, sir. I was wondering when that question was going to come up. So the question was, how much data do I really need? And it depends. I wouldn't be a consultant if I didn't say it depends at some point. So I've done data mining algorithms with 800 records, and it's as much as 5 million records or 30 million records. So it really depends on if you can kind of find pattern in those 100 records. All right, guys, I'm going to hang out as long as you guys need me. Just come up here, and I'll be happy to answer your questions. Yep. All right, thanks a lot, guys. Appreciate it. Don't forget your Thank you.